In the history of biogeography, we will be discussing about the history of marine biogeography. So, biogeography of ocean is similar to that of continents, and then, of course, it is called marine biogeography, and it is not very much different from the continental biogeography because both of them are concerned with the biota of vast areas of the surface of the globe. But they are different because of the nature of environment and of the organism it contains. So environment is aquatic, which is much more different than the terrestrial environment, and it has different selection pressures, it has different set of organisms. So both of them are different, yet they are studied in the same way. So first of all, there was James Dana in 1853, who divided the surface of waters into several different zones based on the mean minimum temperature. So on the basis of temperature, he divided the surface waters into different zones. And then comes the Edward Forbes in 1856, published 5 depth zones and 25 faunal provinces along the coast of the continents. So he studied the coasts of the continents, and on the basis of the his studies, he divided all of them into 5 depth zones, depending upon that how much water they have, and the 25 faunal provinces. In 1880, Albert Gunter published a book on fishes in which he recognized the 10 different regions in the distribution of the shore fishes. And then there comes the Arnold Ortman, published work based on the distribution of crustaceans such as crabs and lobster, and it has the similar work as the Albert Gunter. In 1981, Atlas of Biogeography was assembled by the 3 British zoologists named as John Bartholomew, William Clark, and Perry Grimshaw. And it had the 30 maps of the distribution of fishes based on the pattern of distribution of 27 families. An influential review was also carried by the Swedish worker Sven Ekman. He was a German in his work was presented in German language in 1935, and it had an English translation in 1953. So this divided the faunas of the shallow seafloors into 7 mainly climatic. That means they depended on the climate areas. The work of Sven Ekman was also including the. He said that the Panama Barrier must have been absent in the past. So, what is Panama Barrier? The two of the continents, which are the North America and South America, they are joined through the strip of land which is on which we have the Panama. And on the eastern part of that, both the continents, there is Atlantic Ocean, and the western part is having the Pacific Ocean. So he said that in the past, both that Panama Strip was not there, and therefore it was not separation. There was no separation, and this he was the first scientist to say that. And he said that island-free East Pacific acted as a barrier to the dispersal of the organism. So the East Pacific is the ocean which is present alongside the western shores of North America as well as the South America, and it is devoid of any archipelagos or the major islands. So that's why you see that if an organism has to go, it may have some pit stops in the way. So Eastern Pacific is devoid of any of those island because it is not very geologically active. So what happens that there is less and less movement of organism, especially the terrestrial organism, into the western part, which is towards the Hawaii or maybe towards the Marshall Islands or the eastern part, just like the Japan, across that date line, you can say. And he also explained the phenomenon of bipolarity, where a species is found on the either side of equatorial regions, but not within them. So equator is here. A species may be found above the equator or down the equator, but it is not found in the equator because of the different condition on the equator. But up and down, they are relatively temperate areas, and both are having much more similarities. So both those areas are containing certain type of organism which are not present on the equator, and he said that as a bipolarity. So this is the Sven Ekman said. And there comes the Jack Briggs. He in 1974 wrote the Marine Zoogeography. Briggs used the patterns of endemicity of coastal faunas to identify locations where there appears to be zone of unusually rapid faunal change, and then used to this to distinguish 23 zoo geographical regions. So what he did, that he identifies some organisms which are living in a particular zone, and where the set of those organisms change, that is called a faunal change. So he, based on this, he had the 23 zoo geographical regions. And the recent advances, just like we have the ability to explore the depth of the seas, right? So we have ability to sensing and recording the satellites in space. So we can explore with the help of different instruments that we have produced. We have excellent cameras that can go deep inside the oceans. We can have the cameras in space which can look on the globe as a whole, and we can observe the biogeography in real time. That's the ability that we have recently developed. We have reached to the deepest part of the oceans, and we have discovered one of the last found ecosystem, just like the strange hydrothermal vent faunas. So hydrothermal vents are the vents which are present on the ocean floors, where there is some water coming out of the hydrothermal vents. Hydro means water, thermal means heat. So these are the, जिसे हम उर्दू में कहेंगे गर्म चश्मे ocean floor पे. And then there is the nimbus, which is a satellite. It monitors and records the changing patterns of planktonic life. So we have much more advances in the form of satellites and newer technology to observe, record these different changes. And now we are at much more, rather than recording the history, we are also observing the changes in biogeography in real time.